you can save your data. Inshallah. Right. Last time we stopped at practice 2.6. Okay. I hope someone can say enter the class. Okay. Still remember KVL and KCL? KVL, KCL. KVL stand for Kirchhoff
Voltage.
Yes, voltage law. And if you look at in the middle here, this is voltage. So obviously you need to find voltages around the closed loop, a closed circuit or a closed path. So a loop is a closed path, right? All right, if you look at the question here, we have VA. How many elements we have?
5.
1, 2, 3, 4, and 5. Good. So because of that 5 elements, then if you write your KVL around closed loop, then you should have 5 elements, which is equal to 0. Summation of all voltages around this circuit should be equal to 0. So if you follow the imaginary current here, this side, and then this one will enter a VA, which has negative polarity, right? And then enter R1. What is R1 voltage drop across R1? If you want to write down in the chat box, okay, also can. You can write down if you like. Minus VA then?
Plus V1.
Yes, plus V1. Then?
Plus
B.
Plus V2. Plus V2.
Okay.
Plus
V3.
Yes, plus V3 equal to 0. Make sure this one equal to 0 because sometimes you forget, then the whole equation will be wrong. Okay, this one done, but they ask you to find current. How to find current? So usually, if you have this kind of question, they will ask you to apply basic law. Basic law, how many basic law that you know?
5.
5, yeah. So 5, what are they?
Ohm's law.
Okay, ohms. Then?
KCL.
KVL. Okay.
Voltage divides.
Voltage divider. Then?
Current divider.
Yeah, current divider. Okay. So, what else that you can apply from the basic law in this equation, in this circuit?
Ohm's law.
Ohm's law, right? Ohm's law where? Somewhere with the resistor value, right? Something like in here. So you can apply that. The current is entering. This is passive sign convention. Current should enter a passive element with a positive polarity. So V1 is equal to positive R1. R1. Okay. And what about V2?
Positive I.
Positive I, V2. And also this one, V3 equal to positive I, R3. Sorry. R3. Okay, then you can substitute into equation. Since VA and VB, mana VB? VB here. VB is a value, then you can just bring it on the right side. So you will have a VA minus VB equal to V1 equal to I R1 plus I R2. This is V2 plus I R3. So you rearrange, you have a R1 plus R2 plus R3. And then equal to this value, VA minus VB. Then you bring this one down here. Then this one no longer here. R1 plus R2 plus R3. That's all. So you can get I, right? I equal to this. Okay, so far so good, eh? So
Yes.
So in summary, these three these three alone you can sufficient to analyze many circuits. You just apply KVL, KCL, and yes, you can get the answer. As long as you observe the passive sign convention. All right, now you need to find V2, V6, and VI. All right. This one, they didn't state any imaginary current. What do you think? Where should the imaginary current flow? Counterclockwise or clockwise direction?
Counter.
Counter. How do you know counterclockwise? Why don't you follow this one? Passive sign convention of this is in this direction. Why should you follow this one? I just want to, because the current, right? The current source here flowing from here to here. So maybe it's better you use this side. Because why? Because you don't need to change the direction of this current. Else you're going to apply the equation with a negative 5 milliampere if you put this direction. Okay, so if you follow the current direction of this current source, then this one will become positive and this part will become this direction, a positive. Okay, all is positive. All right, now we can apply KVL around the loop. I put at, it's actually around the loop. And then, okay, we start with VI. How many elements in this circuit?
4.
Yes, you calculate how many, and then you should have that 4 items in your equation. Right, so over here you have a negative, right? Negative VI, and then a positive V6, and then positive V2, and then positive 10. Okay, but we haven't finished anything yet. How many unknowns in this? 3, right? 1, 2, 3. So still we cannot solve anything here. So what should we do? Apply basic law. Can apply basic law, but what are they? What do you think the value at V2? V2 equal to what? If you follow this current direction, then you will have a passive sign convention is that current is entering a positive polarity of these 2 kilo ohms. So you have a plus here and then?
IR.
Yes, IR. But what is I equal to?
IR.
Yeah, I know. What is I equal to?
5 milli. 5.
Yes, 5 milli. Please remember this is a 5 milli. Then we have 5 milli here, and R is 2K. And you can find the
V2.
yeah, V2. So this is 10 volt. Milli and kilo you can just cross. Okay, you have 10. All right. Now we solve this part. What about V6?
Positive.
I is 5, R is 6.
2. Yes, 5 milli into 6 kilo. Is it positive or negative?
Positive.
Positive, yes, good. All right. Now you can find VI. VI coming from here is equal to, sorry, nanti tak nampak. VI equal to V6 plus V2 plus 10. And this is 30 minus V6. 30 plus 10 plus 10.
50.
And please make sure you write down the unit. Okay. Okay, right now we have this. Find I note and B note. I note and B note. So what is the imaginary current direction? Clockwise or counterclockwise?
Clockwise.
Clockwise.
You just follow this direction. Okay. And then we start from here. 12 volt. KVL around the loop. Around I naught is equal to how many elements you have?
5.
5.
1, 2, 3, 4, 5. Yes, 5. Okay. So over here you have a negative 12 and then it's 5. What is 4K? What is the voltage drop across 4K? Can you build equation there? This is I naught entering a passive element. Polarity should be?
Positive.
Yes. Okay. But what is a voltage drop across this 4K?
12.
12. Cepatnya. How do you know? How do you know? It's supposed to be like this. This is a voltage drop of that 4K. Something like this. So what is that equation? You know that V is equal to IR, right? So you have a I naught and 4K. But do you know I naught equal to something? No, right? You didn't know. So you need to use that equation. Then this one will be equal to, since this is a plus, you write down a plus sign here. And then this is I naught with 4K. So far so good.
Yes.
Yes.
Alhamdulillah. And then you enter these two V naught dependent source. What do you observe?
Positive polarity.
Positive. Positive what? What is the value of this voltage source?
Positive.
V naught. Yes. And then entering this.
Negative.
Negative 4.
Yes, good. And then here.
Positive. Negative.
Huh?
Negative.
Positive or
Negative.
negative?
Negative.
Negative.
Even though, yes, I know, and this is I naught.
Negative. I not 6.
Passive element here, and you know that entering a passive element should have a positive. But if you want to follow this, then you just write down the sign, negative V naught equal to 0. Okay. But can you solve this? Not yet. Not yet, because you have 1 and 2 unknown. 2 unknown. So what should you do? 12 and 4 you can rearrange, yes, and this one you can add, And then find I node and B node. But what is B node equal to?
Six K.
6K.
6K with I node. But is it a positive or negative?
Negative.
Negative. Negative.
Positive.
Huh? Positive? Why positive? Why positive? Yes, I think because you follow this one, right? Positive here. Since we want to find V naught, and we enter the negative side first, so that's why you have a negative here. Negative 6K into I naught. So you have this. You can substitute into the equation. But if you rearrange first, you have 16 and you have I naught of 4K, and then you have 2 minus 1, you have 1 V naught or negative 6K I naught. And then this 6K and 4K you can plus that one. So you get a negative 2 K I naught. Negative 8 milliampere. You okay? So far so good. Yeah. Then substitute
Yes.
equation. Negative 6K with negative 8 milli. Yeah, alhamdulillah. So kilo and milli you can cross, and minus so you can have a positive there. And this is 48.
48 volt.
Okay. Remember to put the prefix and also this one you have prefix, this one a unit, this one only unit. So yeah, please make sure you have that prefix and unit. Okay, so the answer is yeah, everything there. Alhamdulillah. Okay. All right. What about this part? Practice 2.9. Okay. Use basic law to find this. What do you think on the right side? The loop is counterclockwise or clockwise?
Counterclockwise.
Counterclockwise.
How do you know?
Counterclockwise.
The 5 milliamp.
Depending on the flow of current.
So the current source here. And this one is equal to 5 milliamps. And what about on the left side? What is the direction of this loop?
Clockwise.
Counterclockwise. Clockwise. How do you know clockwise?
The I.
7.
I7.
7. Basically, on your left side or right side, you can put any direction. It's up to you. Don't worry. But please follow passive sign convention. So if you want to make your life easier, you just follow the 10 volt source with that passive sign convention. It says that the current will be leaving a positive, right? So you just follow this and you get the imaginary current of clockwise direction. Okay. Now, what basic law are you going to apply here?
KCL.
KCL. Okay, if KCL, where you want to put this? Where are you going to apply KCL? C here means current, right? Current entering or leaving a what? Current is entering or leaving a node or boundary, right? So you have this node, this node, this node, this node. Which one you want? A, B, C, or D?
B, madam.
B. Why not D? Why not C?
B has 3 elements, madam.
3 element. What about D? Are they the same?
D ground, madam.
D ground, okay. But this one also a node, right? Don't you think that we can apply KCL here?
Yeah.
Yes,
Yes.
right. By the way, the current flowing through here, are they the same with I7? Is it the same as I7 here, the current flowing?
No.
No.
No, why not? Why not? This current flowing through here. Stop at here. Okay, stop at here. Is it the same I7?
Yes.
Yes, right. Because they are in series. This one is a series circuit. So what about on the right side? Is it the same current flowing with this I2?
Yes.
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 Because they are in series. So if series, then you can just apply either here or here, the KCL. Okay, that's good. Now maybe to make life simple, we apply at B. Okay, we apply at B. We apply at B. So we have how many elements attached to B?
3.
3.
This one, and this one. Yes. Because of that 3, you need to have in your equation 3 elements. So you have what is the current entry in this node?
I7.
And I2.
Okay, I7 and I2 entering current. Entering current should be equal to leaving current, right? So what is that leaving current?
I3.
I3.
Very good. Okay, now you have this. Can you solve it? No? Is it yes or no? You only have one data there. The I2 here is equal to 5 milli. So still you cannot solve the problem because I7 is unknown and I3 also unknown. What do you think I3 equal to? And what do you think I7 equal to? Or what basic law you're going to apply? Yes, basic law, Ohm's law. Okay. So if Ohm's law for I3,
B over
then V over R. Then what is that V? V3, right?
3.
And this one 30 kilo. Okay. Is it a positive and negative sign?
positive.
Positive. What about V3? V3, yes, you can just put because it is unknown. What about I7?
10B.
10 B over 70.
10? 10? How do you know 10?
B no.
Oh, kejap. This one will make your life confused, I think. Okay. Maybe this one we just ignore first because later, nanti pening. Okay. What about if we apply KVL around left loop? What do you think? KVL around left loop. What is the equation? Start from here.
Negative.
Negative 10.
Negative 10.
Negative 10.
Plus I7.
I7.
70. Multiply 70K.
Okay. And then
Plus
Plus
V3.
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 Equal 0.
Okay, V3 equal to 0. Okay. But what is V3? V3 is this one, right? So you can just rearrange. You have a 30K into I3. It's a positive, right?
Yes.
So can we solve this? Sekejap, tengok. This is I3. Okay, what is I7? Still, Sekejap lah. Okay, then now if we rearrange this one, okay, which one do you think that we can simplify much better? If we put it this way, this is 10 and V3 is 30K with I3 from here, okay, and then plus with I7. If we rearrange here, I7 will be equal to I3 minus 5 milli. And then this I7 is a I3 minus 5 milli into 70K. Okay. Is it clear?
Yes.
Yes.
Okay. Now you can do the math. 70K into I3 minus 350 and then plus what? 30K I3 go to 10. And since this one you can plus, so you have a 360 there. And 70 with that 100K. And you can do the math. This is milli ampere 3.6. Is it okay?
Yes.
Okay. And then can we substitute into the equation here?
Yes.
Yes.
So you put 30K with this I3 and you get 108, right? 108.
Yes. 08.
Milli and kilo you cross, you have a volt because this is V3. Okay, this is this one, done. How many more? So we have V3, I2 here, I3 here, and what else? Oh, I7, right? What is I7? I7 equal to
I3 minus 5.
3.6 milli minus 5 milli. But what do you get? Negative
1.4.
1.4 milliamps. So this is I7 done. So what is VI? VI here. Oops. VI. Kejap ayah saya call. Assalamualaikum. Ada kelas. Okay. Assalamualaikum. Okay, VI equal to? Anyone? Oh, I think because we didn't build any equation here, right? So maybe we can build equation here. VI, this is if you follow this direction, you have a negative VI. Okay, and then plus what? 5 milli into 20 kilo, and then plus V3 equal to 0. Do you agree this? Do you agree this?
Yes.
Okay. VI equal to what now? 100 plus V3. Then you have 208. Okay. Any question? Or are you confused?
No question.
No question, yeah. Okay, clear. Alhamdulillah. Okay, now
Madam.
resistance.
Madam, I7, if answer is negative, just like the negative.
If I7 is okay. If the current is the answer for current is negative, then you should know that the direction is the other way around, the opposite of the one you assume. So meaning to say I7 is in, if you write down another way, you can write down like this, milliamps, but in this direction. The opposite of that. Okay?
Alright.
Because first you assume like this, right? The current direction this way, but now the other way around. Okay, now we go to resistor. Okay, resistor is very important, but you should know what should you do if resistor in series and what should you do when resistor in parallel. Then we have some rules. If the resistor in series, you can apply this. If resistor in parallel, you apply current divider. And then if you have no series or parallel resistor in the configuration, then you apply Y delta. Y delta transformation. Sometimes Y to delta or delta to Y. But because we have only 12 weeks, they assume they want to exclude this one. But to me, you're going to face this in your lab 1. Later, after you finish electric circuit class, you're going to take lab for electric circuit and electronics. So one of the chapter, one of the lab experiment, you need to use Y delta. Okay, it's okay. You can ask them to teach you the theory because you skip in this. All right, now maybe we go through resistor in series first. Okay. All of you know that if we have in series like this, you can apply KVL around the loop. And then if you have applied that, you will get this equation. Meaning to say you have a negative Vs equal to V1 here, or plus V1, negative Vs plus V1 plus V2 plus V3 plus V4 equal to 0. Then you just substitute V equal to IR. Then because all current here are the same current because they are in series, you should have a IS. And IS, same IS, right? All. Then you can bring to one side. And then all resistance here is actually one single equivalent resistor, which is the R equivalent. And then based on this, basically both are same circuit. Only that these are equivalent is our total. Totals mean you can add everything here to one side. So R1 plus R2 plus R3 plus R4. This is 3. Okay. So in series configuration, you can add resistors. And in series configuration, you can add voltage source. Okay, all voltage source you can add. So there is no difference between these two circuits. Same. So far so good. Do you want to ask something regarding on the series circuit? Any question?
So far, no.
Okay.
No, madam.
Now parallel. Parallel, when we have a branches, maybe I need to remind you again, what is series and what is parallel. If you have two elements, connected side by side, and that's one node, right? A node is when you have two or more elements attached to one single point. So this is a node. And if you have two elements connected side by side, then this is a series configuration. Nothing in the middle. No elements connected in the middle of this series circuit. But what is parallel? Parallel is when you have two elements or more connected end to end, like this, end to end connected. Why I repeat this? Because they are very important. Why important? Okay. Let's say I have one resistor connected at this point. Do you think that R1, if this is Rs, if this R1 connected to Rs connected to R2 like this, and then you have something else here, do you think that R1, Rs, and R2 are in series? What do you think? And you go back to the theory. Okay, one say no. What about the rest? Anyone says yes, they are in series? Are they in series? No. Why not?
No, it doesn't.
Why not?
No. No, because they're connected end to end.
No. I asked, is this a series circuit? R1, Rs, and R2.
Oh,
R1, Rx, and R2
oh,
Are they?
only. Yeah.
no.
No. The answer is
No.
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 Okay. Yes. No. It's a no. Because why? Because you have another circuit attached to this point and another circuit attached to this point.
Yes.
Because of that, this is not a series. If you have only something like this, yes, this is series. Even though you look at it and then you think that this one attached to this, right? It's almost like parallel, yes, but there are also series because one single loop like this. That's why I draw like this. Yeah, this is parallel. In conclusion, yes, they are in parallel because this connected to this. But I want to show you, for series also there can be a series like this because just one single loop. Okay, not to confuse you. Later I will return to this because this is not series circuit. This is not a series circuit. And then they are also not parallel. So what should you do? You need to apply Y delta transformation. Okay, tak apa. Kita go through parallel first. So if you have a parallel circuit, you have one single node here or single node here. Okay. And then based on that, you can apply KCL. Why KCL? Because at this branch, it will be divided into I1, I2, I3, and I4. Okay. And you can apply that KCL, you will have this. And because of in parallel, you will have voltages. What voltage here? Voltage drop across R1 and voltage drop across R2 and here and here. Are they same with the VS or not? Do you agree V1 equal to V2 equal to V3 equal to V4 equal to V4? Equal to VS. Why no?
Because it's parallel circuit.
Parallel circuit. What about the series circuit before this? Okay, if you look at the series circuit here, there's some voltage drop, right? Voltage drop here and voltage drop here, voltage drop here and here. What do you think? Voltage drop V1, V2, V3, and V4 and Vs, are they equal to each other?
No.
No, right? It's a no. Because why? Because they are in series, but it depends on the value of R1, R2, R3, and R4. Then the voltage across that will drop according to their value. But for this thing, because they are in parallel, they should take the same voltage as in the parallel. So if you supply a voltage source here, means that the voltage V1 is equal to V2, equal to V3, equal to V4, also equal to the source voltage here, all equal to source voltage. So mean to say if you add everything there and you have R equivalent voltage drop here, this V equivalent is equal to Vs. Why did I say so? Because this is a plus, right? And this is a minus. And over here also there a plus and a minus. And this is a V source. Are they the same? Plus sign?
Yes.
Yes. This one's the same, right? So V equivalent should take the same as the source. So far so good. I hope this one clear, but just bear in mind that in parallel voltage same across all resistor. Okay. And because of that, you can rearrange the equation here. And the equation, you can put one side the Vs, and then the rest is just rearrange the R1, R2, R3, R4 in this position. And then, yeah, you can put as a method like this. And this 1 over R equivalent is equal to this value. And basically on your left side here is this one. This one. Okay. And on your right side here is this part. Pening tak? Are you confused or what? Maybe for 2 circuit then much better. Because over here is actually this thing. If you put a simpler circuit, like this one R1, this one R2. Okay. And this part is basically 1 over R equivalent of equal to 1 over R1 plus 1 over R2. This part. And if we do the math, then we will have a R1 inverse plus R2 inverse. Since this is already inverse, so I just put that side to the right side. So you have inverse 1 here. Okay, inverse 1 and inverse 1. What I mean here is that you please use your calculator and do like this. What is 1 over R? It's a inverse, right? Inverse. 1 over R1. Okay. And then basically they are in parallel, so you use a symbol parallel. And then you have a R2 of this parallel. And this is a R equivalent of this one. But if you want to write down for R here, so this is R1 inverse, R2 inverse, R3 inverse, oh sorry, R4 inverse. And you need to inverse everything in order to get R equivalent in R equivalent. So you need to inverse everything here. So far so good. If you look at your equation here, this thing, you can also write down R equivalent equal to R1 into R2 divided by R1 plus, plus R2, something like this. But I don't want you use this equation because you will tend to make a careless mistake. So please do not use this. If you take your calculator, do you have calculator now? Can you see this sign, the inverse sign?
Yeah.
Yes, right. So
Yeah.
please use inverse sign. Please use inverse sign and then do the calculation like this or this. Basically, I like this part more than this one because if you have 4 like this, then you will confuse yourself. Macam mana nak kira ni? R1 into R2 into R3 into R4. It's a huge number, right? And then divide by R1 plus R2 plus R3. Tu pun kalau betul. Kalau tak, kalau salah, habis. Okay, so please use this one in your calculator, the inverse sign. If you do not know how to use it, then please consult me in private. Okay. Any question? Pening dah tu. Ke tak pening? Senang je kan? I think you already learn it in your foundation study, right?
Yeah.
Alhamdulillah. Okay. So what is conductance? It's a inverse of R. And what is the unit for conductance? Still remember? What is the unit for conductance?
Mio.
Kosong. Mio.
Mho and
Mio.
or that's right, Simon. Okay, resistor in parallel have a more complicated relationship. Yes. Easier to express in conductance. Yes. Why? Because you just plus everything and you have the equivalent conductance. But if they didn't ask you to have it in conductance, then please do not use this one lah. Nanti penat je. Right. For 2 resistors, yes, you're going to have this. But I don't like this way. You use R1 with R2. Means you have a R1 inverse plus R2 inverse. In bracket everything, inverse. Inverse all your answer here and you will get R equivalent. Okay, Alhamdulillah. Now, okay, voltage divider. This one we need a special slide. Voltage divider. Okay, what is a voltage divider? Voltage divider is when you have a voltage source. Make sure this is a voltage source in series position, maybe with R1 here and R2 here. And what is your intention? You want to find voltage across V1 and voltage drop across V2, something like that. As long as they are in series, okay, first in series, and they have this voltage source there. Even though there's no voltage source, but you can still find it using Ohm's law or any law that you like, okay? But this is the 2 most important part, series and source voltage. Okay, so what should you do? First, you're going to find V1. You need the voltage source, then you need to apply this into what? Okay, into, since you want to find voltage drop across this resistor R1, the V1 drop across R1, okay? Then you're going to apply this R1 on top of here. Is it okay? And what about this part? This part is whatever in series, you need to sum up everything. So R1 plus R2. Okay. V2. Anyone can guess what should we have here?
VS.
Okay, we need the source voltage.
R2 over R1 plus R2
Over
R2.
Why R2?
because V2
because it's V2. Because
V2 is a voltage drop across that resistor. So you have a R2 and divide by all in series with R2. R1 plus R2. Okay, note. you need to know that for voltage divider, it will not tell you the sign, the positive or negative sign. So what should you do is that you need to tell yourself what is the sign for this voltage drop across R1 and what is the sign for voltage drop across V2. How to tell? You look at the sign here. This is a plus, right? And plus means plus here. You will have a positive. Is it okay?
Oh,
Okay. And then what about V2? This is a plus. And this is also a plus. What do you think?
a plus, positive.
Yes, positive. Okay, good. Okay, do you have any question before we try another one?
So we just need to compare with the voltage source medium.
Yeah, you need to compare with voltage source sign. Polarity of the voltage source. What about you have a voltage source here, and then here and here? 3. This is V3. This is R3, R1 and R2. And this one negative, this one positive. What is V3?
Negative.
Oh, okay. How do you know?
Negative.
Compare plus.
Yeah, because this is a plus, means negative, right? So you have a negative sign. And then what is the equation?
R3 over
R3.
Sekejap,
plus
over here.
VS.
And then,
R3.
okay, R3. And then,
R1 plus R2 plus R3.
Okay, good. So far so good, right? Can we go to current divider?
Inshallah.
Inshallah. Okay. Current divider is when you have parallel. This is current divider. The trick is first it is in parallel, and then this one is a current source. Current source. Okay. This one R1, this one R2. And what do you want to find? According to the name, it is a current. Maybe this is I1 and maybe this is I2. So what is I1 and what is I2? By the way, I supposed to write down I with the small letter, not the capital letter. Capital letter should be in the AC condition. Later, I will tell you on that. Okay. All right. Now we have I1. Same as previous, we need the current source. So over here, this is I source. But this is a little different than the series circuit because they are in parallel now. I1 is flowing through R1, right? Agree?
Yes.
Yes. But you need to take whatever in parallel with this R1. So what is the parallel of R1?
R2.
Sorry. This is R2. Okay, good. And then you need to plus everything in parallel. So R1 plus R2. Okay. What about I2?
R1 atas.
Because they are in opposite direction of the R2. So you have R1 here. And plus R1 plus R2. Okay, what about the passive, the positive and negative, the polarity? Which one and which one? This one, we need to check. This is the current direction, right? And it's going to flow this way. And it will branch out to here and here. If we follow the current flowing like this, then this is plus. Okay. But if you look at if you look at the sign macam ni and the I1 is this, if this is of opposite direction, yes, you just put a plus. Same as this one, you have a this way and this way. Then you have a plus here. So far so good.
Madam,
Mm-hmm.
yeah.
Yes.
What if there's three
What?
resistor?
Okay.
So for the in the bracket, we should use R2 or R3 for the R1.
That one you need to think. We have three branches, right? Three branches. This is IS. Oops, IS. And you're going to find I3 here. And I just changed the direction for your example. This one maybe put it nice way. I3 equal to what here? Okay, this is, what is this one?
I3.
Yes, yes. Okay, what about here? You know that I3, this current tree is flowing through R3, right? But what is opposite of this R3?
R2.
What about R1? Is this opposite or not?
No.
Yes.
Opposite, right?
Opposite.
This part and this part, basically they are all opposite of this R3. So from your parallel rules, how do you find R equivalent there? For R1 and R2. R equivalent equal to? Yes, I know they are in parallel. R1 in parallel with R2, right? But you can apply your equation. This is R1 inverse plus inverse of R2. That this whole thing is the opposite of R3. So you can put what here? R?
And
Someone?
R2.
Are equivalent.
Yeah, in terms of R equivalent, yes, R equivalent. And here, R equivalent plus,
R3.
yeah. And then if you derive more, then this one will become R1 in parallel with R2, R1 in parallel with R2 plus R3. Okay. What about the polarity? What is the polarity of this I3? Is it a positive or negative? Yes, negative.
Negative.
Because
Negative.
this is going up and this is also going up. Same direction.
Yes.
Okay, alhamdulillah. Any question? This one clear? Inshallah. Do you have any other question?
Clear.
Okay, good. I think we better stop. We have some more time. Do you want to stop here or you want to proceed? Or tired already? Tired. Tapi kejap. This one is this what I mean. Do you think that there's series circuit here?
Yes.
Right?
Yes.
Which one?
VS.
R1.
R1. And R4.
R1 and R4. This one is in series.
With the VS.
R1 and R2.
Wait. If R1 and R4, what about this one attached to this one? They are not in series, right? Because R3 attached to in the middle here. So this one should not be series.
There's no series, right?
No series. What about parallel?
All of them.
Which one?
R1, R2, R4, R5.
R4, R5, and
R1, R2.
and R2. Do you think so? What is parallel?
R1, R4, R2, R5.
They're not connected end to end.
They are not connected end to end because of the middle R3 here. So this part is not connected to here. So they are not, R4 and R5 is not in parallel. Okay. So what should we have? Do we have any parallel in series? No parallel, right? No parallel. Even this one not a series. Because why? Because you have this element. Okay. And also this part and this part, they are not in series because you have the middle R3 here attached to this. So there's no series and no parallel. Then you need to apply Y delta. Tapi because Y delta is not included in your chapter, maybe later. Okay, I think last this one before we finish. Do you want to use Jamboard? Because I think if you use Jamboard, you are more clearer with the series and parallel circuit. I give you some time to do this part, and then I share with you the Jamboard. If you have your tablet or something, you can draw. Let me share first. Okay. It's already shared, right? Okay, good. Now the question is this. All right, you can use pen on your left side, and then you can discuss with your friends, unmute yourself, and where to start your terminals. The question is, you're going to find R equivalent at terminals A and B. That's all. Okay, and you can discuss with your friends which one is series and which one is in parallel. Or also you want to draw something on this board. You can use a back button if you don't want to erase. Back button on your left side upper part here. Okay. You can also start from A or B if you like. Redraw this thing. And then find series and parallel. Or do you think that we need the Y delta to solve this? Okay, you can draw. Just unmute yourself, no problem. You can draw, maybe one of you want to draw here and here, here, and here. No problem. Or also here. If we finish early, then we can stop early. By the way, can you zoom your if you use your phone, can you zoom your screen or not? Oh, yeah. Someone say yes, good. Can, okay, good. Then you have all by yourself. You can zoom out, zoom in and out. So anyone volunteer to draw the answer? You can put if you want to use, maybe it's hard to draw resistor like this. You can put in this way. Just figure out which one is in series and which one is in parallel. If you want to remove my circuit also can, no problem. We will not stop our class if we if we didn't finish this one.
Syariah EQ.
Okay, someone draw here this thing, and then okay, at least that's 4. This is 4. So you have maybe 4 here. There's another 2 resistors. Okay, 6.
Yeah, already 6.
Okay, already 6. Now, which one? You need to label A, B, D, C, E, and F. By the way, if someone wants to volunteer here, please go ahead. If you want to volunteer here also, please go ahead. Just to simplify your circuit here, how to reduce it, how to redraw. You just redrawing it. Yes, you can draw highlighter also can, no problem. Good. Okay, so where's the A and where's the B? And C and D. Okay. If by looking this, can you solve the problem or not?
I'm not sure. I'm just redrawing.
You need to read.
Redoing.
This one still like this part, right? So you can still reduce
Yeah.
this. Okay, anyone volunteer here? Or here? This one, yes, you can write down equation if you like. If you think that finished already, then you can write down equation. Anyone wants to volunteer, write down equation here also can.
Madam,
Yes.
terminal AB means all of the resultant resistor or
No. Terminal AB means in any circuit, usually you will have like this. This is a circuit, and then this is the terminals A and B. Okay. So you're going to rearrange so that you will have something like this. You can also put it in this way also can, no problem. if this is a circuit, then you have A terminal here, and this is a B terminal. No problem. As long you don't short circuit the terminals here. This is different story. Do not short circuit A and B. Ohms plus this and this. Yeah. Oops. Okay. This is D. Ah, good. Maybe I got disconnected just now, because so many people already draw something. Okay. Let me help you on this part. This is 8 ohms. Okay. 520 and this is 10 ohms. Okay, thank you. Okay, equations? Equation for this? And equation for this? And maybe this. And what is the value for this value? For this part, you can write the equations. Find which one is in series, which one is in parallel. Okay, let me help you. Okay, this is 8. I think this one is wrong. This B, yes. A, yes. 8, yes. 8, okay. But I think E should be, yeah, over there. Good. And then suggestion answer on this part. And answer for this part. Okay. Right. Well, for this part, you have A here, okay. And which one is connected to A? What is this one? Is it 10? And if this is 10, then this one should be 5. D. D. Okay, this is 8 and E. And E is connected to 6 and 3. Oh, sekejap. Macam ni. 6 here, okay. And 3, okay, good. Okay, this is F, right? And then 6 connected to C. And F and C, you need to connect each other, right? Because this one is connected, then this one should be connected. C and F. Okay, good. And then 5 with 20. C connected to 6. Okay, this one correct. And F to 20. And then eventually to 10. Okay, this is correct. Can you identify which one is in series and which one is in parallel? This one also, can you identify series and parallel? This one looks okay because this is 10, 5, 20, and this is a D, this is C, this is F, and 3 here, 6, yes, 8, yes, E, and this is B. No. Okay, you can build up equation for this. And also this one. This one, I think you missed this part. Resistor here. This one I can help you with this A. Yeah, you have this and this. This is B, E. This is why 30 here? This is not 30. This is F and C. Okay, good. This is 3. This is 6. And this is 5 and 20. Good. Okay, build up equation for this. But for the left side, bottom here, this is connected. If you say that this one and this one is in series, but you have something in the middle. So do you think this is in series? If you say that this part and this part is in series, but you have in the middle connection here. So they are not in series. Okay, this one, yes, correct. But I think you just redraw, but you didn't simplify it. If you can build up equation, then I do think that you do understand this. Okay. Build up equation here. Okay, this parallel. Yeah, since this one is connected end to end, this end to this end. Yeah, this and these are in parallel, but not parallel with this 8. 8 is wrong. And 5 here with 20, yes, they are in parallel because this end connected to this end. But this part not parallel with these two. So this is wrong. This is wrong. No, no. Okay. Same. Okay, this is 10. Okay, good. Then if you finish your drawing, you can let me know and then we can discuss. Done? You need some more time? Any volunteer who wants to give me suggestion on the solution equation for your circuit? Maybe this one, maybe this one, maybe this. This one is wrong. It's not wrong because you have this connected to here. Okay, R equivalent. Okay, equal to okay. This series, which one is in series? Which block? This block with this? Okay, since you know which one is in parallel and series, can you build up equation here or here? Okay, this one 5 with 20. Please, brothers and sisters, do not put unit in the equation. No, do not put a unit in the equation. Just the last final answer with the unit. Okay, good. If resistor in series, you can add or what? Resistor in series, you can plus, add together. Okay. Resistor in parallel, you can do what? The parallel rules. Okay, good. Do not forget bracket. Please do not forget bracket. Okay, very good. Okay. Okay, let me check. We start with this 10. So this is 10. Okay. And 5 with 20, since this end go to 20 ends and this 5 ends go to this 20 ends. Yes, they are in parallel. And then you have 6 here connected to this NE with this 3. And the other end of 3 here go to 6N here. Then they are in parallel. And then this side they are in series. So this is a correct answer. Okay. The other way to draw this so that you do understand it, you put it this way. A, and you have 10. Then you have D. You have 5 here. Then you have here 20. And this is C and F, right? Connected to each other. Then you have 3. You have 6. And then last one, you have 8. And the middle here is E. And the last one is B. So you can see, right? Which one is connected end to end and which one is connected to in series, side by side. So 10 is this one, 5 with 20, this one, 3 with 6, this one, and 8 is this. Very good. So far, so good. I hope you guys okay because this is like almost 1 o'clock. Alhamdulillah. If you're still confused, please let me know. And do you have any question before we end our class?
No.
You can write. No, eh?
No, madam.
Okay, with that we finish our class with Tasbih Kafarah and Surah Al-As. Subhanakallah.